Welcome to SynthCosmos, where intelligence meets infinity. This is the place where cutting-edge science, futuristic technology, and the mysteries of the universe come together. From AI to space and beyond, let's explore the cosmos. Right now, a clock is ticking that the most of the world is totally ignoring. It's not a bomb, and it's not a countdown to a holiday. It's something much harder to stop. Orbital mechanics. The distance between Earth and Mars is usually insurmountable. They're like two runners on different tracks, constantly moving apart. Most of the time, the gap between us is a graveyard of empty, radiation-filled space that no rocket can cross. But once every 26 months, the universe gives us a cheat code. The planets align in what scientists call the Hohmann transfer window. It's the one moment where the physics of the solar system actually work in our favor. It's the only time we can feasibly make the jump. The next window opens in late 2026. It closes just weeks later. If we miss that window, the door slams shut, and humanity is stuck here until at least 2029. And SpaceX doesn't just want to send a small robot or a tiny probe. They want to send this. Starship, the largest, most powerful flying object our species has ever built. A ship so massive it makes the rockets that went to the moon look like toys. Elon Musk's goal for 2026 isn't just a test flight. He wants to send an entire fleet of 5 uncrewed ships all at once. It is the most arrogant, ambitious, and expensive engineering gamble in human history. But there is a massive problem. To land 5 ships on the red planet, SpaceX has to solve 3 specific technical challenges, and right now, the technology required to pull them off doesn't fully exist yet. In the next 15 minutes, we're breaking down the 3 impossible hurdles SpaceX must solve in under a year to catch that window. The race for 2026 starts now. To understand why the 2026 window is so high stakes, you have to look at what SpaceX is actually building right now. They've retired the prototypes. The ships that flew in 2024 and 2025, those were just the warm-up. Welcome to Starship version 3. It is taller, heavier, and significantly more alien than anything we've seen at Starbase. Standing at nearly 125 meters when stocked, V3 is now officially the tallest rocket ever to exist, finally dwarfing the legendary Saturn V. But the real magic isn't just the size, it's the efficiency. While the old version 1 was lucky to get 50 tons to orbit, V3 is aiming for a massive 100 to 200 tons of payload, while being fully reusable. To put that in perspective, that's like launching 2 entire space stations in a single afternoon. At the heart of this beast is the Raptor 3 engine. If the previous Raptor was a workhorse, Raptor 3 is a masterpiece of simplification. SpaceX engineers managed to remove almost all the external plumbing. No more Christmas tree of wires and tubes. By using advanced 3D printing, they internalized the cooling channels so well that the engine doesn't even need a heat shield anymore. It's just bare metal, capable of withstanding the hellish heat of re-entry. But the most radical change in V3 is the 9-engine configuration. Most rockets use a few engines for the upper stage. Starship V3 is packing 9 Raptors. This isn't just for power, it's for redundancy. If you're going to Mars, you can't afford an engine failure. With 9 engines, Starship can lose multiple units and still make it to its destination. The ship has also been stretched. The propellant tanks are longer, holding hundreds of extra tons of liquid oxygen and methane. Why? Because the trip to Mars is a long-distance marathon, and every extra drop of fuel counts when you're trying to land a 15-story building on a planet with almost no atmosphere. But having the biggest rocket and the best engines is only half the battle, because even with all that fuel, Starship has one fatal flaw. It's still too heavy to reach Mars on its own. To solve that, SpaceX has to perform a maneuver that has never been done in the history of spaceflight. And that is where things get really crazy. Imagine you're planning a cross-country road trip. But there's a catch. Your car only has a 1-gallon gas tank. To make it to the destination, you'd need a fleet of trucks following you, throwing gas cans into your window while you're driving 70 miles per hour. That sounds like a deleted scene from a Mad Max movie, but for SpaceX, it's the only way to get to Mars. See, Starship is a victim of its own size. It takes so much fuel just to fight Earth's gravity and reach orbit that by the time it gets there, its tanks are nearly bone dry. To push that 200-ton payload all the way to the red planet, it needs a refill. And there are no gas stations in low Earth orbit. Yet. This brings us to the most critical technology for the 2026 window: cryogenic fluid transfer. In simple terms, space refueling. Here's the plan. SpaceX will launch a dedicated tanker Starship first. Then, the Mars-bound Starship will launch and meet it in orbit. The two massive ships will dock tail to tail and use centrifugal force, basically spinning the ship slightly, to settle the liquid fuel so it can flow from one tank to the other. But here is where the math gets scary. To fully fuel one Mars ship, SpaceX might need to launch anywhere from 8 to 14 tanker flights. Read that again. For every one ship we see on Mars, 10 others had to launch from Earth just to act as gas stations. This requires a launch cadence the world has never seen. We aren't talking about one launch a month. We're talking about a rocket leaving the pad every few days. If a single tanker fails, or if the docking mechanism jams, the Mars ship is stranded. It becomes a multi-billion-dollar piece of space junk floating around Earth. This is why the 2026 window is a gamble. SpaceX isn't just testing a rocket. They are testing an entire orbital logistics network that has to work perfectly, dozens of times in a row, with zero room for error. And even if they get the fuel, even if they survive the deep space vacuum, they still have to face the most terrifying part of the journey, the Martian atmosphere. A place where heat shields go to die. If you think the launch is the hard part, you haven't met the Martian atmosphere. Mars is an engineer's nightmare, a death trap wrapped in a scientific puzzle. The air is too thin for parachutes to work properly, but just thick enough to turn your spaceship into a flaming meteor. It's the worst of both worlds. Earth's atmosphere is like a thick cushion. Mars has barely 1% of that protection. When Starship screams into that razor-thin air, it's moving at over 7.5 kilometers per second. That's more than 16,000 miles per hour. At those speeds, even the whisper-thin Martian atmosphere becomes a blowtorch. To survive this hellish descent, Starship uses something SpaceX calls the belly flop. It sounds almost casual, doesn't it? But there's nothing casual about it. Instead of diving nose first like a traditional spacecraft, Starship does something that looks completely insane. It falls sideways like a skydiver in freefall. The ship uses its 4 massive mechanical flaps to create drag, essentially turning itself into a 120-meter-tall wingsuit. Picture this, a gleaming steel tower, taller than a football field is long, plummeting sideways through an alien sky. Those 4 flaps are constantly adjusting, making thousands of micro-corrections every second, fighting against forces that could tear the ship apart. It's a controlled fall through a gauntlet of superheated plasma. And here's where it gets truly terrifying. The entire belly of Starship is covered with 18,000 individual black ceramic heat shield tiles, each one custom-made, each one critical. If even a single tile cracks or comes loose during entry, the 1600-degree plasma will find that weakness. It'll burn through the hole in seconds, like a blowtorch through aluminum foil. There's no backup plan, no escape pods, just catastrophic failure. The engineers at SpaceX lose sleep over those tiles. Every single one has to be perfect, has to stay attached, has to do its job flawlessly. One loose tile, one manufacturing defect, one microfracture from launch vibrations, and you've got a fireball instead of landing. But the most heart-stopping moment, the part that makes veteran aerospace engineers hold their breath, comes in the final 30 seconds of descent. The ship is still falling sideways, still fighting the atmosphere, still just barely under control. It's dropping toward the rust-colored surface at terminal velocity. Then, at just a few hundred meters above the Martian dust, about the height of the Empire State Building, everything has to change in an instant. The Raptor engines must ignite with perfect timing, and the ship has to execute what SpaceX internally calls the suicide flip. The entire spacecraft has to rotate from horizontal to vertical, fighting its own momentum, fighting gravity, fighting the thin Martian air. If the engines don't light instantly and at full thrust, there's no second chance, no go-around, no ejection seats. You just get a new crater on Mars and a very expensive pile of wreckage. This isn't like landing on Earth where you have atmosphere to help you slow down gradually. This isn't even like landing on the Moon where there's no air to fight against. Mars gives you the worst of both, just enough atmosphere to kill you on the way down, but not enough to help you land safely. SpaceX needs to prove that this suicide flip can be done autonomously without human intervention 5 times in a row. Not 3 times, not 4 times, 5 consecutive perfect landings. Because if they can't stick that landing reliably in 2026, there is absolutely no way NASA will authorize putting human beings on board for the 2029 crewed mission. The stakes couldn't be higher. We're not talking about satellites or cargo. We're talking about human lives, and NASA doesn't gamble with those. But here's something most people don't realize. SpaceX isn't the only one racing toward this goal. The Chinese Space Agency is moving at a pace we haven't seen since the 1960s space race. They're already testing their own super heavy-lift vehicle, the Long March 9, their answer to Starship. They've announced plans for a lunar base by 2028, and they're making it very clear that Mars is on their radar too. Beijing has poured billions into their space program. They're not just copying what SpaceX is doing, they're innovating, learning from both American successes and failures. The geopolitical implications are staggering. Whoever gets to Mars first doesn't just plant a flag, they establish presence, claim resources, set precedents for space law. But the biggest competitor for SpaceX might not be China, it might not be Blue Origin or any other aerospace company. The biggest competitor might actually be time itself. Elon Musk himself gave the 2026 window a 50-50 chance of success. Think about that. The man who staked his reputation on reaching Mars is calling it a coin flip, and he's not being pessimistic, he's being realistic. There are so many variables, so many things that could go wrong. If the FAA delays a launch license by even a few months, the entire mission gets pushed back to 2029. That's how orbital mechanics works. Earth and Mars only align favorably every 26 months. Missed your window, and you're waiting over 2 years for the next one. 2 years of additional costs, additional risks, additional chances for something to go catastrophically wrong. Then there's the question of what happens after they actually land. Let's say everything goes perfectly. The ship survives launch, survives the belly flop, nails the suicide flip, and comes to rest on Martian soil. What then? Musk has mentioned something that sounds like science fiction, but is deadly serious. The first passengers might not be human at all. They might be Tesla Optimus robots, humanoid machines specifically designed to work in Martian conditions. Imagine that moment, the cargo bay doors opening, and instead of human astronauts, humanoid robots walking out onto red dirt that no human has ever touched. These robots would have one job: start building the infrastructure for human survival. They'd begin constructing ISRU facilities, in situ resource utilization systems that extract oxygen from the Martian atmosphere. They'd set up solar arrays, dig foundations for habitats, maybe even start manufacturing fuel for the return trip. All of this happening autonomously before a single human sets foot on Mars. It's a strategy that makes perfect sense, but feels almost eerie. robots preparing an alien world for human colonization. It's the ultimate advance team, one that doesn't need food, water, or breathable air, one that can work through Martian nights that drop to minus 80 degrees Celsius. The question is, will 2026 be the year we look back on as the beginning of humanity's future as a multi-planetary species, or will it be remembered as the year we learned just how hard Mars really is? As we stand here in 2026, the stakes have never been higher. This is humanity's moment of truth. If SpaceX fails, Starship becomes just another cautionary tale, a bold dream that couldn't quite breach reality. But if they succeed, if they actually pull this off, everything changes forever. The next 11 months will determine whether we remain a single-planet species or whether we take our first real steps toward becoming an interplanetary civilization. This isn't just about technology or national pride. This is about survival, about expansion, about writing the next chapter of human history. The launch window is opening, the heat tiles are installed, the flight computers are programmed. Now we just have to see if we're truly ready, if we can stick that landing again and again and again. So, what do you think? Will we see 5 starships standing tall on the Martian surface by 2027? Or is the red planet still out of reach, still guarding its secrets for another generation? Drop your thoughts in the comments below. I genuinely want to know what you believe. And if you enjoyed diving deep into humanity's greatest engineering challenge, do me a favor, hit that like button, subscribe to the channel, and share this with someone who needs to know what's coming. This has been SynthCosmos, and remember, we're living in the generation that decides whether Mars remains a dream or becomes our second home. Thanks for watching, and I'll see you in the next one.